So hello everybody. Thank you for joining this webinar. We will be talking about how to turn on great productivity by making the switch. So we'll be exploring the benefits of using the latest Windows and Intel industry standard architecture. And we will go into detail and showing you the benefits on lower TCO, mission critical viability, open server architecture, improved performance, easier maintenance, and ongoing and future compatibility.
Thank you, Tony. Hello, everyone. So the evolving data center getting to cloud, if you start on the left-hand side of this diagram, you see kind of the situation today where there's silos of infrastructure trapped in legacy IT.
So you've got some silos that include legacy RISC, legacy mainframe, and x86. Moving to the center of the slide, the midterm, here you've got cloud infrastructure for mainstream enterprise, but you still have dedicated infrastructure for mission-critical systems. And then long-term, the objective is to have a robust cloud infrastructure for all workloads. And you could actually argue that midterm is maybe a better reflection of where we are today. So how is this going to happen? How are we going to make this transformation? Well, I still remember the first time when x86 systems could be virtualized, and there was a very significant performance hit. That was many years ago. Today, there's actually near native performance in virtual machines, and the reason we have that is that Intel works very close with the hypervisor vendors such as VMware to make sure that is the performance in the VM is good. Also, the system resources that are accessible by an individual virtual machine have been increasing over time. So, for example, the amount of memory that can be addressed within a virtual machine and the number of virtual CPUs that can be supported. So we start on the upper left-hand side of this diagram, escalating demands. So we all know today there's more devices, more device types, and more data. IBM has been quoted as saying that 1/3 of all digital data in the world is due to medical images. So on the medical imaging side, that's definitely contributing greatly to this. Moving to the right, evolving data center models. Touched on this a bit in the prior slide, but moving from discrete silos of compute to more of a virtual and then ultimately cloud infrastructure. On the bottom left, the compounding challenges. So of course, security is one of the key challenges that we have. There's the threat of a breach and the negative consequences of a breach of information. So making sure that not only are the regulatory requirements supported, but that we minimize the chance of a security breach and a breach of protected health information. Storage is a challenge, so dealing with just the large, ever-increasing volume of data. Mission-critical availability, of course, we're going to talk about that a bit later in this presentation in more detail. And then I'd really like to talk about power and space limitations as the challenge. What I hear from a lot of enterprise customers when they talk about the data center is density. So trying to get the greatest density out of their existing data center square footage. So depending on who you talk to, this could be characterized in terms of computation or computing per square foot. Sometimes I hear it in terms of virtual machines per square foot, but really without needing to expand onto new real estate, getting the most out of a data center in terms of density. And then finally, in the bottom right, IT spending pressures. So this is a conceptual pie chart, of course, with different categories. The takeaway is that the blue portion, keep the business running, is too large. Now I'd like to talk a little bit about how Intel fits into this, balanced data center solutions. So most people think of Intel as a chip company, and rightfully so. That's a big part of what we do. That would be represented here on the left-hand side of the diagram, with compute. We also have very significant teams and resources working on the networking and storage side. So really, the three legs of the stool when it comes to data center or cloud. The reason we do that is to make sure that to the extent we can control it, we effectively minimize any system bottlenecks that might take place. So we don't want to introduce a new processor and have it starved for have the solutions starved for I/O. So that we work on all of these to create the balanced solution, and just like the three legs of the stool analogy I used, if any of the legs are too long or too short, the user experience suffers. But by making sure that there's a high very high-performance network infrastructure in place, tiered storage architecture that might include a traditional spinning disk, but also a high-performance tier of solid-state disks, and so forth. You can minimize those bottlenecks. I also, on the storage side, wanted to touch on the fact that it wasn't very long ago, maybe 5 to 7 years ago, when much of the storage industry was based on kind of more proprietary ASICs for compute. Today, that industry has effectively moved to the Xeon processor for compute. EMC, as an example, is 100% based on Xeon. So this is from the IDC US and worldwide install base and server forecast. So on the left-hand side, you can see the state of affairs in 1996, where 44% of servers that were installed were non-x86, so this would be primarily RISC architecture, and 56% of the installed servers were x86 based, which is the architecture that Xeon uses. Fast forward to 2016, so of course this is an estimate based on the data and the trends. In 2016, IDC estimates that 98% of the installed base will be x86 architecture and 2% RISC. So, why is this graph important? Well, as one is the trend, so you can see the industry is moving toward x86 architecture. A more subtle point is that the some of vendors that support server architecture, the talent pool of administrators that are trained to manage these systems kind of moves with these trends. So there's a large pool of qualified administrators, ready to work on these systems, ready to manage them, which might not be the case with proprietary RISC architecture or RISC systems. Here, we can see some data on specific unit volume as it relates to SPARC Solaris. So you can see the trend for SPARC over the years from 2000 to 2012. And so it's not only the percentage of deployed servers that are moving to x86, but actually the unit volume is decreasing on the SPARC Solaris side. These are a couple graphs again from IDC survey. Side, you can see Unix migration plans. So this is not specific to healthcare; it's cross-industry, but you can see some of the application types listed in the y-axis. Here, we see that it varies from 57% to 72% of organizations that are either currently migrating away from their current server platform or highly likely to migrate. So the significant majority are either migrating currently or highly likely. On the right-hand side, this shows what operating system platform they're to. Just across the board, you can see that Windows is the operating system that they're moving to fastest. Why these migrations are taking place? Well, if we start at the upper left, cost reduction. So of course, there's IT budget squeeze and increasing project costs. I touched on this a little bit earlier, but I'll raise the point again that the kind of a hidden cost is around the support or maintenance. So oftentimes, a large application like a PAC system or electronic health record and so forth in healthcare might use more than one server architecture and operating system. By standardizing on one architecture, so as Carestream has done, replacing Unix with x86, you can manage all those systems with the same talent pool. You don't have to have a separate person whose expertise lies in kind of proprietary Unix architecture. Couple that with the fact that there's just more administrators out there that know how to manage these systems, and the support costs can be significantly decreased once this migration has taken place. Demand for performance, a concept called power efficient performance. I talked about density in the data center earlier and some of the challenges around power and cooling. So it's not just raw performance, but it's also performance per watt. So how much cooling do you need? How expensive is cooling and power? And how dense can you make the data center in terms of computation per square foot? So all of those performance and power efficient performance considerations are also driving these migrations. On the lower left, business challenges. looking to drive utilization, server utilization up, or CPU utilization. That gets into why, or one of the key benefits of virtualization and moving to the cloud. I talked about space and consolidation, power and cooling. Some of the customers we've talked to are still using Unix. I mean, they're using some of the older systems that can literally be the size of the refrigerator. Today these systems in many cases can be replaced with a small 2U system with the same performance and much lower power, much lower footprint. So you can fit more of them into the data center. And then finally, platform strategy. The one point, so we talked about standards-based architecture. Again, what do we mean by that? So moving to the x86 architecture, Intel is not the only x86 manufacturer, but even more importantly, there's a large number of server OEMs, HP, Dell, IBM, Cisco, that are all developing solutions on that architecture and competing for business. So the result of that is cost goes down and quality goes up, and when you have that kind of competitive environment. So ultimately, it's very good for the customer.
So these surveys are from IPIC. On the left-hand side of this slide, you can see the data from 2009. These are unplanned hours of downtime per year on several different computing platforms. So you can see on the right-hand side, the same survey was conducted 2 years later, and you can see some of the big improvements. Most notable for this presentation is the Windows Server on x86 improvements versus some of the RISC platform alternatives. You can see with Windows there was an 11x improvement in that time frame, and really it's at parity or even better than some of the RISC platforms. So what drove that improvement? There's actually several factors. One is the improvements in the hardware. So Intel previously focused its RAS, or reliability, availability, and serviceability features to our Itanium architecture. We have brought that capability down into the Xeon architecture as well. So really a focus on the mission-critical availability features in the hardware. But even more importantly, the reason for that increase is that more and more users of those servers are deploying mission-critical applications that have much higher SLA requirements than they may have had previously. So there's really a combination of factors that led to this. But the important message is that Windows on x86 is at parity from a mission-critical availability standpoint with RISC alternatives. About performance and availability, I want to talk about some other features of the architecture. So here, what is hardware-assisted security? So what do I mean by that? In the past, most security functionality is enabled in the software. So you can think of encryption or even antivirus or anti-malware kind of applications. Those run kind of at the operating system layer. To performance challenges, but also the kind of the sophistication of some of the attacks we're seeing in the data center from a malware perspective. Intel's strategy is then to take some of that core security logic running in software and move it directly into the processor or into the hardware. This makes the resulting security solution higher performance, but also a stronger level of security. Again, you saw from earlier data that one of the top challenges or top concerns in the data center in healthcare that relates to security and privacy and the threat of a breach. So I want to talk about one specific example of this. There are many examples of where Intel has worked to do this, but one very relevant to today is around encryption. So, the trend in healthcare and enterprise in general is to, part of this is a result of cloud and virtualization, part of it is a result of mobility, but moving the protections to the data as close to the data as possible. And so one example of that is around encryption and what happens when you encrypt data repositories that may not have previously been encrypted. Say in the data center, whether it's a database or a file system, or even data in transit over the wire in some cases, is that the experience for end users can suffer. If you're encrypting something today that wasn't encrypted before, the performance can be reduced, and there's a concern from both software vendors and end users. How can I mitigate that performance hit? So Intel has something called AES and I. AES being the most commonly used symmetric key encryption algorithm, NI standing for new instructions. So we've taken the core elements of this encryption algorithm and supported that directly in the processor in the form of new instructions. So when software uses these instructions, they get hardware accelerated encryption, and this is available in any of Intel's processors. This example shown here is from an electronic health record solution, a report solution, where they were able to double the performance of their reports. The benefits in this case to an end user would be either getting reports faster or requiring a smaller number of servers to do the job. Carestream is in their next version of the software is going to be taking advantage of AES and I for data in transit. So this would be data that is encrypted over secure connections to end users in the data center. So users of the PAC solution. So again, they'll take advantage of this capability in the next version of this software. Talk a bit about the tick-tock strategy at Intel. So some of you may have heard of this before, most of you probably haven't. In the early 2000s, Intel had some challenges when we tried at the same time to introduce a new processor architecture and also simultaneously move to a new, smaller manufacturing process. So say to the 45 nanometer manufacturing process, shrinking the die. So the strategy that our CEO at the time, Paul O'Leary, put in place was tick-tock. So on alternating years, Intel will either introduce a new processor architecture or shrink the process, shrink the manufacturing process. And when you shrink the manufacturing process, the result of that is higher performance and lower power because the connections get closer together, everything gets smaller, and so forth. So there's great benefits for that. So you can see that we have executed like clockwork on this strategy, from 2007 all the way through, going into the future, going into 2014 when we're going to introduce our 14 nanometer process. And at each introduction of the processor architecture, new features are added. You can see some of those highlighted here. So, for example, more computing cores, a larger cache, really gets into the power efficient performance side. But then there's also, features you may not, at first blush associate with the processor. Like I mentioned, hardware accelerated encryption. We're going to talk a bit later about some of the instructions that have been added specifically to boost performance of algorithms like image processing, of course relevant to Carestream. So this is the message to take away here is that this is a kind of a regular cadence. It's been repeated for a number of years now, and we see it continuing into the future. So the innovation going forward is very strong. This chart for two industry standard benchmarks, SECN and SEC-SP. 2006 is not the year. That's just the name of the benchmark. You can see the performance of the E5 2600 series, which is typically the platform that Carestream would be deployed on. The Intel platform Carestream would be deployed on. In the red bars, you can see an Oracle Spark T2 and T3 series and how those compare in these benchmarks. This is available on Intel.com along with many other industry benchmarks. We'll note here that there was no data available for these benchmarks for the Spark T4 or T5 series, so that's why those aren't listed here. To highlight some of the key benefits of the open standards-based x86 server architecture. So first on the supportability, from the supportability standpoint, so of course you've got the very large x86 install base from a volume perspective. Again, it was well over 90% of the market is moved to x86. So this lets customers and software vendors standardize on one server architecture. So you don't have one application that requires multiple operating systems, multiple CPU architectures, and subsequently have to train staff and administrators to operate on both. Highly available, so we looked at some of the availability numbers, but x86 on Windows Server is now at parity with RISC architecture, and better in some cases, according to the data. We didn't really talk much about VMware vSphere, but as a bit later in the presentation, when Tony goes through the architecture, virtualization is an option for Carestream customers. So if the availability data we looked at was really focused on the platform itself. When you virtualize, for example, using VMware vSphere, you get the benefits of even more advanced high availability features. So distributed resource scheduling, VMware HA, high availability, and so forth. So this is an additional layer of high availability functionality on top of the underlying platform that organizations can take advantage of. I've worked with other software vendors in the past who introduced virtualization in their solution primarily to get access to these features. So it can really be a big bang in terms of high availability. And then finally, flexibility and cost. And this is driven in large part by the fact that there is a large number of OEM vendors to choose from, highly competitive environments, which again, has the benefit of driving down costs and improving quality. So a couple case studies. The first is from Eli Lilly. Many of you recognize them as pharmaceutical manufacturers on the life sciences side. So in this example, they were migrating and virtualizing their SAP environment from a RISC platform to Xeon. And really, their key challenge was not only that migration, but making sure it would be highly scalable and highly reliable. So they made the migration from RISC to Xeon. They optimized the software for the x86 architecture and virtualized their DB2 database using VMware vSphere. With this particular example, they were able to show multi-million-dollar savings and a 2-year payback on any hardware investment because of lower costs in the hardware and lower support costs. On the power and cooling side, they eliminated a large number of servers as a result of this migration because the newest servers were higher performance, and they reduced power and cooling consumption by over 80%. Of course, that also helps with cost and helps improve density, the density in the data center that I mentioned. And then finally, the performance increase they achieved. Performance went up by 40 on some of their modules, but the overall performance gain was 11% across the board. So 11% performance increase across the board at the same time you're eliminating 35 racks of servers. So this case, I want to mention that this case study and the next case study we're going to talk about, in addition to a number of other resources, are available there's links at the end. So when you get access to these slides in PDF form, you can read this in detail or any of the other resources that are provided. With the Carestream medical imaging case study, the key challenges that this case study details are accommodating more detailed images, high resolution, larger file sizes, and scaling globally with high performance. So why did Carestream move to x86? Well, from a processor standpoint, the Oracle Spark strategy is really to use a very large number of smaller cores, whereas the Xeon or x86 processor uses a smaller number of high performance cores. And it turns out that the Xeon approach was much more favorable to the performance of Carestream's algorithms that they use on the imaging side. Furthermore, Intel has worked very closely with Carestream to optimize their algorithms for x86. One example of that is that we help them take advantage of, our software team, software and solutions group, help them take advantage of something called the SSE4 instructions that are supported in our processors. So this drives parallelism into the platform and lets the imaging algorithms take advantage of that. SSE4 and the new instructions called AVX2 that were introduced in our latest Haswell architecture are specifically aimed to improve the performance for a number of different kinds of algorithms, and image processing is one of those high priority targets that we're looking to boost performance. And so, Carestream has adopted SSE4, and now that Haswell has been introduced, we're going to be working with them on AVX2 as well. So really, not just getting the out-of-the-box benefits of Xeon, but working very closely hand-in-hand with Intel to optimize their image processing algorithms specifically to run, best on this architecture. Up front, I talked about balanced data center solutions. So if you get a chance to look at this case study, you can see how, not only in the compute side, but we work closely with Carestream on the networking side, specifically on 10 gigabit Ethernet networking to converge the network and storage traffic on that one fabric. So this can, if you're interested, you can see how this drives down costs and really makes the data center solution less complex by having this converged network. So the benefits here are listed below. Images processed 28% faster than the previous generation of Xeon processors. More users supported at customer location, so higher scale, and reducing the cost and simplification of the infrastructure. So, I think one of the important things of this case study is really, it's not only just the kind of industry standard benchmarks. We saw the Xeon compared with Spark a few slides earlier, but really what's most important is how real world applications and workloads will perform on the platform. And I would say that the work that Intel and Carestream have done to optimize their algorithms on that platform is going to really shine when you start using these systems.
So now I will focus a bit more on the Carestream specific architecture. For those who have a Carestream PAX, that will be more speaking to you. I created here a general architecture to show the different modules and how they articulate and work together. And obviously the goal here is to present the different architecture between a Solaris Spark architecture compared to the Intel Windows architecture. So as you can see on the slide, we have the modality on the right side, on the left side, I'm sorry, sending to the view PAX, which is has the gold database. And this is accessed by the radiologist, so the image could be viewed by the radiologist, and he can dictate his report. We have another module above, which is view motion. This is for clinician, usually in the hospital, so they can have display of the medical images and the report that was created by the radiologist. So this is usually a different system. And the system is, the ViewMotion server is Intel-based because we did development specific to that because the viewing of the image, the rendering, the calculation of the image is done on the server, and we send the image pre-calculated to the display. So all the calculation is done on the server side based on Intel processor. And so we can use, the clinician can use a very low-end PC or even a tablet, for example, an iPad or things like this. So all the calculation is done on the ViewMotion, which is Intel-based. We can have a first server, which is on top, which is MyView server. MyView is for the patient, so the patient can access his patient information, image, and report according to what the hospital decided that he could have access to. And if he goes to his referring physician, for example, he can also pull out the images for that. That's replacing the CDs kind of. So those two servers, which is, again, the rendering on the server side, they use Intel CPU, the one at the top. And at the bottom, we have the archive, what we call the Clinical Data Archive, CDA. So this is the archive, could be also Oracle-based, and even, centralizing all the data for several hospitals and even synchronizing oversight, as I'm showing here, another PAX at another site. So from, that's the kind of a typical architecture. So we have 4 servers to have these 4 features. functionality. If I switch to the same architecture in Intel Windows, we have less server. I kept the My View separated because it's accessed through the web, so there's potentially a security issue, so it's behind the firewall. So even though if I can kind of merge it with the ViewMotion, I left it separate. In this Intel architecture now, we have ViewPacks and ViewMotion, which is in the same server. That's our typical installation to put the two together, assuming that the packs and the ViewMotion are in the same version. And we also converted the archive, which should be a separate system, as also an Intel server, forwarding to another pack system at another site, synchronizing, which is an also system. So here we have reduced one server. We can do even more, but the logical configuration would be this one. So by going to Intel, you have all platform on the same architecture, all Windows Intel, so it's simplified for the architecture and the support. And also we're removing one server from the architecture. We can also do a VMware implementation or virtual environment. So here we're going to have one virtual system, one physical system into the hospital or in the data center. And this will have 4 virtual machines. Since now we're talking about virtual machine, it's better to separate all the different functionality. And we could put a MyView server for the patient access, a ViewMotion for the clinical access, a PACS for the radiology access, and the archive. All of this could be coming from one physical server. There's also some advantages of virtualization. We can support the VMware HA, which is the high availability, where the system has one virtual machine that comes down. Automatically, VMware can restart the application into a different server and restart the functionality. So that's also something that we can do with virtual machine. I just wanted to kind of summarize now the reason for making the switch. The main one would be to have an industry standard open platform architecture. Obviously, this is to have the standard infrastructure, the most common infrastructure that people have, and that's the trend of the market. You have also a wide choice of supplier, if you like Dell, HP, IBM, and many others, where if you are in the Unix, you are stuck with one supplier. If the price increase, if the server is not viable, if the new line of model is not matching your need, it's tough to be into that one supplier model, where if you have the standard open platform architecture, you can purchase this from anybody. Chris talked about several of the architecture improvement, performance. This was the independent testing that he has shown, where the E5 2690, which is what we use into many of our servers, is 3 times more powerful than the Spark T3 for a lower price. So 3 times more powerful, it's important. Viability, we also have shown that there's a reported uptime of 99.997, which is 4.9, which is pretty high. So that's also reported a higher availability than the Unix platform. So that's also very important. We have virtualization capability with VMware. We have a reduced data center footprint with less server, less space required, less power consumption, less heating. So that's even better. Lower hardware price. The Sun Oracle server are very expensive, so that's also why we are focusing on the Intel Windows equivalent. There is obviously the ease of maintenance. I think many PACS administrators recognize that having the skills of Unix, Solaris, and Windows, having multiple skills is complex, so you need to have specialized person, where you most likely have Windows environment in the hospital, so having all into Windows makes more sense. It's easier to maintain. And finally, obviously, we are going into the direction of focusing on Intel platform and Windows, so we'll make sure that any new feature or new version will be compatible with the Windows Intel platform.
My job is to administrate the Carestream pucks and wrist pucks in the hospitals where they are installed. In the data center is in Oslo, but we put in the local satellites. They are all connected, interconnected between each pucks, and with the main archive, the CDA, is in Oslo. It's on Intel platform. We used to have Unix and we changed to the new platform, and it's all running on virtual servers. The images are loading faster, and it's easier to administrate for us, of course, much easier. Now we can go into the server easily, log on with Windows, you can connect to the normal domain servers and everything to connect to that server. It's easier, it's cheaper, and it's faster. We were kind of surprised because the radiologists were quite pleased with the new platform. They of course can't see if it's Unix or Intel. For them it's indifferent. But they say the loading the image is very fast. And they say that Unix is very stable, but I can tell you that the Windows platform this one is more stable than it used to be another one. And it's easy to solve. So it's go faster and we save time. Time is money. We did the migration in different steps. It was 3 different hospitals with 3 different servers, and you have to do different migration. Mainly you can say the users of the system didn't notice which server they were on until we changed the clients. So for them was when one client was installed or 2, they all wanted it when they saw how it was made, and the transition for the doctors was very good. During the conversion period, we didn't have any downtime. We just stored it temporarily somewhere and then reused and moved the data without any disturbance of the production environment. So we didn't notice the migration at all. Virtualization for us is a policy. We say we use that, it's cheaper, it's easier. If the system could run on virtualized servers, we use virtualized servers. It's easier, it's more flexible, it's a cost saving and of course time saving. And the difference between Unix and Intel is quite obvious for us, because like I told you, a lot more people can administrate and can work with the server, because before there were quite a few people, maybe 1, 2 in an organization of 600 people that can access and do something on the server. Now we can go inside to look at the processes and have a look at the server as we like it. Or you can extend or expand the system in a much easier way than it did before, and the system is handling more exams than it did before. What is the benefits of using Unix? That's my question. It's not why using Wintel. No, it's another way around. Why keep on using the old kind of system? Using hardware, use servers. Why use that? It's not more stable.